afternoon. My name is Peter Duplessis. I'm VP of Technology for the Axiom Group. My background is tertiary education in geology, chemistry, soil science, mathematics, statistics, and business. We developed a number of algorithms over the last few years to be applied in the forestry business. All right, so I'll be showing you a number of slides today where we look at forest species inventory by applying remote sensing and machine and deep learning in the forestry business. Our value proposition is predictive data analytics, where we combine terrestrial and other ground truthing data with satellite and fixed-wing helicopter or drone data, and laboratory spectral data as well. And then we take machine and deep learning, where we train different models, and therefore we can automate change detection, and we can get into the predictive capabilities of those systems. It's very much client and outcome focused, our approach to create effective end products. It's all about innovation, but it's also about being cost effective and adaptable to our clients' needs. So we build custom solutions where we can cover large areas, so it can all be scaled up. And we can do this, we believe, better, faster, and cheaper than our competitors. On the right-hand side, you can see an image where we have a soil map on the bottom right, a geology map, and then a forestry map. And these are all things that we do from satellite as an example. As I mentioned, it's about applying artificial intelligence and machine and deep learning. And just a little bit of history here. Of course, it already started in the 1950s, artificial intelligence. And then in the 90s and 2000s, machine learning came into the picture, and really 2010. But really in the last 5 years, deep learning have become a very powerful tool. So we use all of these in our analysis. So here in this image, you can see how artificial intelligence, machine learning, and deep learning, and then data analytics and data science are all integrated with each other. And we can apply that in computer vision, where we can utilize satellite data, UAV, or any other airborne type data, camera data. And that spectral data could be hyperspectral, multispectral, or RGB, or radar data. And we then do a whole lot of image processing, and from there we apply it in a number of practical applications. We also use structured data, which is data that goes into databases or spreadsheets, if you like, and we can really handle high-dimensional data and handle nonlinear data very well as well. And we do the data analytics, and we apply that in a number of applications as well. In this image, you can see a satellite 10-meter resolution vegetation analysis in the Pascoya area in Saskatchewan, up in the forest in the north. And here in this image, the brighter green indicates healthy vegetation. So the darker green, less healthy, and the sort of pinkish color, really clear-cut areas in this northwestern part of the image. And you can see roads and things like that in this image as well. For this particular area, and there you can see that same Pascoya area that I've just highlighted in the previous image is in red over here, and all these colored dots are different tree types where we had tree locations from forestry, and we can then use the spectra from these different tree types to build our algorithms. And we had over 500 locations in the area to utilize. So here's an example of what the spectra looks like. So we got reflectance on the y-axis here, and we have wavelengths on the x-axis. So these are nanometers. And so you start in a visible spectrum at this range here, sort of 400 to 700 nanometers. And then the rest is in the shortwave infrared spectra. And in the visible spectra, they are all pretty close, the different trees, but once you look at the infrared spectra, you can actually separate them very nicely. So black spruce, trembling aspen, balsam poplar, and so on number of different trees, but also bare soil, which would be dirt roads or clear-cut areas, water, separate that out quite nicely. And brushland is everything else that is not trees. We also combined a digital elevation model with analysis, and we do that really to distinguish between different habitats. So you can see areas like this, we had a river valley, and there's a number of them draining in this southeasterly direction. You have different habitats in those river valleys from the surrounding countryside. So by utilizing the digital elevation model that we construct from satellite radar, we can really highlight those different habitats and do the machine learning on those together with the spectral data. So at the end of the day, we could then distinguish between different trees with a high level of accuracy. So here on the left, you can see TA is trembling aspen, bare soil water, white spruce, balsam poplar, white birch, brushland, tamarack, jack pine, and black spruce represented in these different colors. And this is at a 10-meter resolution, and this is very cost effective and it's scalable over very large areas. Here in brown, you can see sort of clear brushland areas over there. Now we can also use higher resolution data, and this is an example of a helicopter multispectral survey that's done at 20 centimeter resolution, and do the vegetation analysis for specific areas where we need higher resolution at this, or even better resolutions. With this type of data, we can get down to 2.5 centimeters if that is required. So in this top image is a RGB image, and you can see there's a trembling aspen forest over here, a road there, of course, and this is grassland surrounding it. And in this vegetation health image, the same area, you can see the pinkish color represents low vegetation health and the bright green high vegetation health. So you can see in this forest, it varies from very healthy part in the back here and less healthy in the front. And even within the grassland areas, you can see different plant health here too. We can then classify it to distinguish different species in this particular area, and you can see in the forest, then we can nicely distinguish between really the healthiest part of this forest and the less healthy part on the southern end of it here. And within the grasslands as well, we can distinguish at different areas, different types of vegetation, but do that at a very high resolution. So it's really about cost-effective data analytics at the end of the day, where we can use data, apply machine and deep learning that leads to efficiencies that in turn saves time and money for clients. And we've developed applications in agriculture, the environmental field, forestry, and mineral exploration to date. But there are, of course, big opportunities to leverage AI within these different fields, and we have a number of other projects under development. That's really what I wanted to show you guys today. Thank you very much, and please let us know how we did. Thank you.